Hi everyone and welcome to week 10 for Junior Cycle Ordinary Level. Today we're going to focus on some practical examples of exam questions. We're going to spend the lesson going through various questions that have come up that you can apply practically. So the first question there, this is from 2018 paper 1. So we're going to go through it. So Martin is saving to buy a bike. He has €100 saved to begin with. He saves another €20 each month. Work out in total how much Martin will have saved after 4 months. Okay, so he has saved €100 already, so that's going to be added in. So it's going to be 100 plus. Now, he needs to save another €20 each month, or he has saved another €20 each month for 4 months. So it's going to be €20 by 4, and that'll give you your final answer. So it's going to be €100 plus €80. So after 4 months, Martin will have saved €180. So the bike costs €240. Work out how many months in total Martin must save in order to have enough money to buy the bike. Okay, so he has €180 already, and the bike costs €240. And what you're being asked is to work out how many months in total he needs to save in order to have enough money for the bike. So if the bike costs 240, we can take €100 away from that because he has that already. So 240 minus 100 is 140. So what he needs is €140. If he is saving €20 a month, he needs to save 140. He can only save €20 a month, so that will give you the amount of months that he needs to save in total. So 140 divided by 20 gives you 7 months. So Martin needs to save for 7 months in order to buy the bike. On to part 3. So for part 3, Lisa is saving to buy a laptop. It costs €320. Each week she saves the same amount of money, and she has saved €50 to begin with. After 18 weeks, Lisa will have exactly enough money saved to buy the laptop. Work out how much she saves each week. So the laptop costs €320. And she already has 50, so take 50 away from that to get the total amount that she needs. That's going to be €270. Now, after 18 weeks, she has exactly the amount of money. So if you divide €270 by 18 weeks, you will get exactly how much money she saves each week. So the total, which is the amount that she needs, 270 divided by the total amount of weeks, which is 18. So 270 divided by 18 is €15 per week. So just make sure that you're showing all of your work for these questions as well. So we'll go on to the second example now. So this is the next question, and it's also from 2018, but it's question 3. That's paper 1. So fill the boxes to make this a linear pattern. Now, if it's a linear pattern, that means that the first difference must be the same. So to get from 10 to 14, we added 4. So we must have plus 4 between each term. So to get from 14 to the next term, we add 4. So that's going to bring us to 18. To get from 18 to the next term, we add 4. And that's going to be 22. Now, how do we get from the first term to 10? We added 4. So that must mean that the first term is 6. So it's 6, 10, 14, 18 and 22. If we go on to the second part, fill in the boxes to make this a quadratic pattern. So if it's a quadratic pattern, remember that the first difference isn't constant, but the second difference is. So how did we get from 2 to 4? We added 2. How do we get from 4 to 7? We added 3. To get from 7 to the next term, we must add 4. So 7 plus 4 brings us to 11. And to get to the next term, then we're going to add 5. So 11 and 5 is 16. Now, to make this a quadratic pattern, we need to check to see is the second difference constant. So to get from 2 to 3, we add 1. To get from 3 to 4, we add 1. To get from 4 to 5, we add 1. So there you have it. You've made it a quadratic pattern. So I'd label these as well. This is the second difference. And then we have the first difference. So that's that question. We'll go on to another one now. So this question is from 2018 and it's paper 1. This is question 4. So a sheet is folded in half a number of times. After one fold, there are 2 layers. After 2 folds, there are 4 layers. After 3 folds, there are 8 layers, and so on. Fill in the table to show the number of layers after each of the first 6 folds. So, how do we get from 2 to 4? We add 2. How do we get from 4 to 8? We add 4. Now you'll notice that this is doubled. To get from 2 to 4 it doubled. To get from 4 to 8 it doubled. So it's going to double again. 8 when you double it is 16. You're going to double it again then to get to the next term. So 16 by 2 is 32. And then double it again. 32 by 2 is 64. So you're doubling it each time. So I'm just going to write that in. Work out the least number of folds that would be needed to have more than 500 layers. Okay, so we need to work out how many folds that you'd have to make in a sheet to have more than 500 layers. So it goes in the pattern of 2, 4, 8, 16, 32, 64. So we'll keep going. We'll double 64, that brings us to 128. We'll double 128, that brings us to 256. And double 256, that brings us to 512. And that is more than 500 layers. Now, from above, we know that number of folds for one fold will give us 2 layers. 2 folds will give us 4 layers. 3 folds will give us 8 layers. 4 folds will give us 16 layers. 5 folds will give us 32 layers. 6 folds will give us 64 layers, 7 folds will give us 128 layers, 8 folds will give us 256 layers, and 9 folds will give us 512 layers. The answer there is 9 folds. You need to answer that. So 9 folds will have more than 500 layers. Okay. There's a part C of this question, I'm going to put it on the next slide because there's not enough room here. Now for part C, you were asked to put a tick in the box to show, or the correct box to show what kind of pattern is made by the number of layers. Only tick one box and justify your answer. Now, the answer to this is exponential, and the reason is because it was doubling each time. Okay, so the first differences are the same as the original sequence. The first and second differences both change, so any other valid reason would work there. But you can just put down that it doubles each time. So if it doubles or triples, it's exponential. So that's the answer to that part. And then after a certain number of folds, there are roughly 1 million layers. Roughly how many layers will there be after 3 more folds? So remember, it's doubling each time. Okay, so if it's going to be 3 more folds, you have 1 million layers. If you're going to double it 3 more times, it's going to be by 2, by 2, by 2. So 1 million by 2, by 2, by 2 is going to bring you to 8 million. So you just have to be careful as to what they're actually asking you there. So 3 more folds. So you're going to double it 3 more times. So you have 1 million and you double it 3 more times, and that brings you to 8 million. Okay, so we're on to the next question now, and this is from 2017 paper 1. So in a raffle, there is a choice of 3 different prizes, A, B or C. The winner of the raffle chooses one prize. So prize A, the winner gets some money each day for 6 days. She gets €10 on day 1, €15 on day 2, and so on until day 6. Each day after day 1, she gets €5 more than she got the day before. Complete the table below to show how much money she gets each day for prize A. Now remember, it goes up by 5 each day. So to go from 10 to 15, we added €5. To get to day 3, we add €5 again. So it's going to be 20. We're going to add €5 again to get to day 4, which brings us to €25. To get to day 5, we're going to add €5 again. That's going to be €30. And finally, you're going to add €5 to 30 to get for day 6, which is €35. So for part 2, what kind of sequence is made by the daily amounts that the winner gets for prize A, and give a reason for your answer? Now, the answer must be linear, and the reason is because it goes up by the same amount each time. So that's what we're going to write in. So it goes up by the same amount each time. Find the total amount of money that the winner will get if she chooses prize A. So we're going to have to add all of these together. On day 1, she gets €10. On day 2, she gets 15. You're adding all these together. On day 3, she gets 20. Day 4, she gets 25. Day 5, she gets 30. And day 6, she gets 35. You add all those in, or put them into the calculator, and you get €135. I'm going to do the next part of that question on the next slide. Okay, so for part B of that question, for prize B, the winner gets €2 on day 1, €4 on day 2, and so on until day 6. Each day after day 1, she gets twice as much as she got the day before. So that means that they're doubling each time. Complete the table below to show how much money she gets each day for prize B. Okay, so €2 is going to double. So we're multiplying by 2, so that's going to bring it up to €4. €4 is going to double, so that's multiplied by 2. That gives her 8. When you double 8, it gives you 16. When you double 16, it gives you 32. And when you double 32, you get 64. What kind of sequence is made by the daily amounts that the winner gets for prize B, and give a reason for your answer? The answer is exponential, and the reason here is that it doubles each time. So then we're going to look at part C. For prize C, the winner gets a single prize of €100 on day 1. Alexa wins the raffle. Which prize do you think that Alexa should choose? Prize A, prize B, or prize C? And give a reason for your answer. Well, let's just write down. So prize A. So for prize A, she got a total of €135. For prize B, we need to find out what she gets for prize B. So the total, we're going to add 2 plus 4 plus 8 plus 16 plus 32 plus 64. So you put that into the calculator, you get €126. And then prize C, you're told she just gets €100 on day 1. So which prize do you think she should go for? So obviously it's going to be the one with the most money. So that's prize A. So the reason is prize A because it is the largest prize. And that's it for that question. So this question is from 2017 paper 1. So we'll have a look and see what they're asking us. So Emma was 4 years old when her dog Spot was born. The table below shows Emma's age and Spot's age at different times. So what it's asking then is to fill in the row in the table showing Spot's age in years given Emma's age. Okay, so when Emma was 4, Spot was 0 years old. When Emma was 5, Spot was 1. When Emma was 6, Spot must have been 2 because it's gone up in 2s. When Emma was 7, Spot was 3. When Emma was 10, Spot was 4. And when Emma was 16, Spot was 5. Now, Spot's age in dog years, so the actual conversion here. So it's going to be 0 to start off with. After 1 year, that's equal to 7 years in dog years. So if it's going up in 7s each time, when Spot is actually 2, what it means in dog years is it's going to be 14. So we fill in 14 here. Now again, if Spot's actual age goes up by a year, if he goes from 2 to 3, this goes up by 7. So 14 plus 7 is 21. Now the way we got from from 21 to 42 is, if you look, you need to be careful of this. Emma's age jumped there from 7, they've written down 7 to 10. So this means you add 7 plus 7 plus 7 to 21 to bring you up to 10, and that would give you 42. And to bring us to 16, you would have to add 7 6 times onto 42, because the difference between 10 and 16 is 6. So 42 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7 would bring you to 84. Okay, so I actually have part 1 and 2 done there. Part 2 is to fill in the row in the table showing Spot's age in dog years given Emma's age. So at the moment, Spot's age is 105 dog years for part B. So it's 105 dog years. Now, what you were asked to do is work out Emma's age in years. So if we actually continued on this sequence here, so 84 plus 7. So it'll bring us until we get to 105, and we'll be able to figure out what age Emma is then. So 84 plus 7 will bring us to 91, and that's when Emma's 17. If we add 7 again, that brings us to 98, and that's when Emma's 18. And then finally, if we add 7 again, that brings us to 105, which means that Emma is 19. So we'll just write in the answer. So Emma is 19 when Spot is 105 dog years. Okay, so we'll go on to the next question now. Okay, so this is 2016, paper 1. So question 1, write down the biggest possible 6-digit number. Well, that's pretty straightforward. It has to be 999, 999. So that's the biggest possible 6-digit number. Write down the smallest possible 6-digit number that does not start with a 0. The smallest possible 6-digit number would be 1000000. Write in the missing number in each of the following sequences. So 3, 5, 7, 9. So it looks like there you're adding 2 each time, which means it's going to be 11 here, because you're adding 2 each time. Let's have a look at the second one. 1, 4, 9, 16. So how do we get from 1 to 4? We add 3. To get from 4 to 9, we add 5. To get from 9 to 16, we add 7. So it looks like it's going up. So 3, 5, 7. The next term there will be 9. So 16 plus 9 would bring you to 25. So you're adding 3, 5, 7, 9. So you'd keep 1 up in 2s there. Let's look at number 3. So to get from 2 to 4, you're doubling it. From 4 to 8, you're doubling it. From 8 to 16, you're doubling it. So if we double 16, that brings us to 32. So you're times 2, so doubling each time. And the last one, if we have a look there, so we're missing the first term. How do we get from 10 to 13? We added 3. From 13 to 16, we added 3. From 16 to 19, we added 3. So the term before 10 must be 7, because when you add 3 to 7, you get 10. So that's that one. It's pretty straightforward. So this is from 2015, paper 1. So that should be Martin. Creates a pattern of numbers using the instructions in the table below. And the first number is filled in. So the instruction, the starting number is 5, the second number is 6, and the third number is 7. So for the rule for this, multiply by 3. So 5 by 3 is going to give you 15. So the second number is going to be 6 by 3. And then the third number is going to be 7 by 3. So then the next bit, subtract 5 from your answer. So your answer here, so 5 by 3 is 15, and you subtract 5, so 15 minus 5. So your answer here is 18, so it's going to be 18 minus 5. And 7 by 3 is 21, so 21 minus 5. So 18 minus 5 gives you 13, and 21 minus 5 gives you 16. So that's the table finished. Martin picks a starting number and using the instructions gets an outcome of 1. Find the starting number that he picked. Okay, so you just have to trial and error and see what works. So he gets an outcome of 1 and he picks a starting number using the instructions. Okay, so if we trial 2 by 3, so 2 by 3, and we take away 5. So the idea here is you have to pick a different starting number that will give you the result of 1. So let's just double check. 2 by 3 is 6. 6 minus 5 is 1. So the starting number that he picked in this case was 2. Because 2 you multiplied by 3. So 2 by 3 you just subtracted 5 and you got an answer of 1. So that one will work. So then when the starting number is k, what is the outcome? Give your answer in terms of k. So if your starting number is k, the first instruction there is to multiply it by 3. So when you multiply k by 3, you get 3k. The second instruction is to subtract 5 from your answer. So it's going to be 3k minus 5. And that's your answer. So that's an algebraic term. So the last one we're going to do is 2014. Paper 1. So question 9. Fill in the first difference and the second difference for the following patterns. Some of the pattern 1 has been completed for you. Okay, so the difference between 2 and 4 is 2. The difference between 4 and 9 is 5. The difference between 9 and 17 is 8. And the difference between 17 and 28 is 11. So then we get the second difference. The difference between 2 and 5 is 3. The difference between 5 and 8 is also 3. And then the difference between 8 and 11 is also 3. Okay, so let's look at the second pattern. The second pattern, how do we get from minus 1 to 2? We added 3. How do we get from 2 to 5? We added 3. From 5 to 8, we also added 3. And from 8 to 11, we also added 3. Now the second difference, how do we get from 3 to 3? We didn't do anything, so there's actually 0. And the same here and the same here. For part 3 of that question, state whether each pattern is linear or quadratic and give a reason for each answer. Okay, so for pattern 1, that's definitely going to be quadratic. And the reason that it is quadratic is because the second difference is constant or the same. If we look at pattern 2, that is definitely linear. And the reason that it is linear is because the first difference is the same or constant. So the first difference is constant or the same. I actually have time to do another question, so we'll do one more. So this one here is from 2014 paper 1. So the question is, the first 3 stages of a pattern are shown below. Each stage is made up of a certain number of shaded discs and a number of white discs. So shade in the appropriate disc below to show the 4th stage of the pattern. Now, in the first stage you've 1 disc coloured. In the second stage you've 2 discs coloured. In the third stage you've 3 discs coloured, which means in the 4th stage you're going to have 4 discs coloured. So I would colour in the ones that are already shaded in, plus an extra one. And that'll give you your marks. So then for part 2, complete the table below to show how the pattern continues. So when we have one shaded disc, there's 5 white discs. When we have 2 shaded discs, we have 1, 2, 3, 4, 5, 6, 7. We have 7 white discs. When we have 3 dark discs or shaded discs, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 white discs. When we have 4 shaded discs, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 white discs. So you can see here there's a pattern forming. You're adding 2 each time. So 11 plus 2 gives you 13. 13 plus 2 gives you 15. In a particular stage in a pattern, there are 21 white discs. How many shaded discs are there in this stage of the pattern? So if I was to continue them on, I'll just continue them on up here. So for 7 shaded discs, so you add 15 plus 2, you'd have 17. For 8 shaded discs, you'd have 19 white discs. For 9 shaded discs, you'd have 21 white discs. So that's the answer there. So there are 9 shaded discs at this stage of the pattern. And the last question, write down the relation between the number of shaded discs and the number of white discs in each stage of the pattern. State clearly the meaning of any letters that you use. So I'm just going to write here. So you will see that each time a shaded disc increases by 1, the number of white discs increases by 2. So there are 2 extra white discs for each extra shaded disc. So we're going to write that down. So there are 2 extra white discs for each extra shaded disc. Now another thing we need to add in is that there is 1 shaded disc and 5 white discs at the start. So there is 1 shaded disc and 5 white discs at the start. So we're going to write that in. So there is 1 shaded disc and 5 white discs at the start. Okay, so that's it. That's a couple of practical examples of exam questions. I'm going to attach, there's a good few more that you can do and you can access from the website. There's video tutorials that are excellent that I'd highly recommend that you follow. I'll attach them to the chat and I will speak to you after Christmas. That's when the next lesson will be. So have a lovely Christmas and I will speak to you then.